This is an update video for the PCUI, or Pocket Computer Universal Interface, with support for the Casio PB-700 pocket computer. And there's also a PB-770, which is an upgraded version of this model here. And functionally, they're almost identical. The PB-770 has some more basic commands, more memory, higher memory capacity, that kind of thing. But both of them use the same printer plotter, which I'll kind of edit in a video demonstrating how that plotter works. And a while back I had restored one of them. The model number I think is FA-10, which has a micro cassette recorder built into it. And the FA-11, I believe, has a full-size cassette tape recorder built into it. So those two models have the same plotter mechanism. And that mechanism is similar to the Sharp and, let's see, the Sharp PC-1500, 1600 is a bigger version. And this version is slightly bigger than the Sharp and Radio Shack PC2 plotter. So it's a little bit bigger, but they all work in a very similar way. And what I'll do is I'll demonstrate the plotting motion that the plotters go through to print. I'll edit that into this video. So the way that those plotters print is they move the pen carousel to the left and to the right, and they push the pen against the paper. There are 4 colors, so it can rotate the carousel and choose red, green, black, and blue for pen color. And it can draw lines, circles, squares, and pretty much line it between any 2 points. And so the x-axis, it just moves the pens to the left, to the right through the carousel there. And then to move up and down, or the y-axis, it actually has to move the paper, or advance the paper forward, which makes sense. But it also has to reverse the direction as well and feed the paper backwards, or reverse feed it, right? So the challenge with these plotters is that they take pens, which you can't buy anymore. They can be refilled, but they eventually wear over time. And of course, the paper for this particular plotter is an odd size, so I had to cut my own paper. There are pinion gear issues, anti-backlash gear issues, all sorts of challenges with that type of printer, and clearly they don't make those types of printers anymore. So the PCUI, if we advance forward a little bit to 2026, this project I've been working on here, which is, if you haven't seen any of the previous videos, this is Pi Pico with firmware that's been designed to interface with pocket computers, various models, one of them being this model here. And what it does is provides printer support to those pocket computers, either serial or parallel. So you can use a serial printer or parallel. I have one of each of these thermal printers. Very inexpensive. The paper is, again, very inexpensive. You can get these used fairly cheaply, anywhere from $20 to $40. Paper is maybe $1 or $2 a roll, or you can use an old dot matrix printer. Pretty much any serial or parallel printer. And the PCUI also supports cassette interface emulation and storing data and loading data to and from a micro SD card. So the PCUI, I've done a few videos on this in the features. So effectively it adds printer support to pocket computers on newer model printers. Ones that are easy to find these days, ones that are inexpensive. You don't have to worry about ink with these thermal printers. No pens, no odd paper sizes. So the PCUI works well for that. And up to this point, and up till I added this new feature for plotter emulation, the PCUI will take the print commands from the pocket computer, translate them, so it'll read them off the bus. So I have this model connected to the custom connector that they're using here. I'm working on a connection pack for this model. Every model that is supported by the PCUI has what I'm calling a connection pack, which is nothing more than the PCUI connection on one end, which goes into the board here, and then the custom or proprietary style connector that goes into the pocket computer. So each each variation of connection style has a connection pack. So this one I'm just reusing a Casio one, the early prototype. I'm just rewiring or rearranging the pinout here and then going in here temporarily. So this is work in progress, so there will be an interface pack for this model. But the idea is you connect the pocket computer to the PCUI, and then the PCUI connects to your printer, your favorite printer, and then you put in a micro SD card in there, and then you select the model on the menu system here. So I have the PB-700 selected. We'd select the same for the PB-770. They're functionally equivalent in terms of the bus interface here. So the idea is if I print from here, it will go into the pocket computer that will read off the bus, and then the PCUI will then output that printer command to the printer. And that works all well and good. But in reading the user guide again for this model, there are a lot of sample programs that come with this pocket computer. And all of them really kind of take advantage of, all the printing examples take advantage of the plotter. And as we know, these modern printers do not have pens. It can't move the paper forward and back. It can only advance the paper one way. And it generally will print from left to right. This particular model, these older ones would print left to right. Sometimes they would print on the reverse path back. These do not do that. They have a fixed print head, and as the paper advances forward, the thermal print head prints the image. So these do not directly speak plotter language. For example, showing an example of the FA-10 or FA-11 or the larger FP-100 plotter. The commands to plot are very simple. You send it a command, say you want to draw a circle, you effectively give it the circle command, the XY coordinate for the start, and then you tell it what the diameter or radius is. And the plotter has the firmware in it to move the paper and the carousel in such a way that it draws a circle. Same with squares, lines, points, etc. So the firmware in these plotters has a lot of data in it for drawing characters and all sorts of shapes and lines, right? So it's very efficient and simple and basic to draw charts and complex drawings using the plotter. And in BASIC, you don't have to do any of the calculations for moving the pens and all that. So that's handled in the plotter. The PCUI, in this example, is going to do that for us. So I've added a new menu in here for plotter emulation. So it could be disabled or enabled. So enabled, currently I have the Casio FA-10, FA-11. As I work with different models, if I find a plotter that has a different command set, I'll add that to this menu. So when we turn that feature on, the PCUI, when we put it in printer mode, it's now listening on the bus for printer commands or data to be put out on the bus, and then the PCUI will listen for that, pick it up, and send it to the printer. Now with the plotter emulation turned on, it's also going to listen for the character sequence to switch to plotter mode or graphics mode. And when it receives those commands, those two characters, it will then store those subsequent commands that would be sent to it, because at that point those are plotter commands. Otherwise it would literally print the plotter commands out. That isn't very helpful, right? So it'll listen to those commands, it'll store them in a buffer, and then when the pocket computer sends the command to return back to character mode, that's the signal to go ahead and go into that buffer, all the commands we saved, draw them on a virtual canvas, so emulate what the plotter would normally do, and then print that canvas from memory out to the attached printer, whether it be Epson point-of-sale receipt printer or a Pro printer or Epson LQ emulation printer. Effectively print that canvas out. So that would, in a sense, give us a plot of what was drawn, right, and in a more modern printer. So let me show a demo of that real quick. So I have the printer mode turned on here on the PCUI. I'll turn on the PB-700. I'm going to switch. I have the plotting program in location 3. I'm going to hit run, and we can see it's running there. And on the PCUI, the calculator receive light is blinking, the LED is blinking. Every time it receives data from the attached Pocket computer, it'll light up. So what's happening now is the Pocket computer is sending the plotter commands, and the PCUI is simply recognizing them and storing them in a buffer. This particular sample program is directly out of the user manual for the plotter that came with this Pocket computer. And it draws a series of circles in various sizes and then moves them along a curved axis. So when it prints out, we'll get a good idea of what that looks like. So the plotter commands are being stored in the buffer in the PCUI, and I've modified the program slightly at the end to switch back to character mode. So I added a single line of code to the example. That, when the PCUI recognizes that command set to switch back to character mode, which it just did, it's printing, it plotted that to its internal buffer or its internal canvas, virtual canvas, and then sending the result to the printer. So in this example, we can see the plot, and this looks just like what we saw in the user manual, or what I saw in the user manual for the FA-10, is a series of circles with, with an axis along a sine or cosine there. So interesting plot, and the basic program is maybe 10 or 15 lines. It's really not that much coding, but again, if you had to do this in bitmap mode, that's a much more difficult process, because the FA-10 understands commands just to draw a circle given a point for the center and a radius or diameter. It's very easy to do this in BASIC. With the PCUI understanding that command set, we can now run programs written for the plotter with this model. We can have the output of that be exactly like the output would have been on the original plotter, which is kind of an exciting feature. Without this feature, yes, you can print from this Pocket computer through the PCUI to a modern printer. So for banners and mazes and all sorts of calculations, whatever you can think of to print, it'll do that. But I was missing a lot of functionality that the plotters provided. So now, with this new plotter emulation feature, it now supports all those plotter features as well. So any programs from the user guide or from the FA-10 or FA-11 guide will work on here, and they'll output pretty much as designed. Now, this was easier said than done, obviously. This feature, although it is a rather simple feature to build, it took a lot of trial and error. So anyway, I'm going to start another program here, and I'm going to keep the printer mode on. And what I'm going to do is go to program 0, or program 2, I think is where I stored it. Let's see. There's a lot of sample programs. Maybe it's program 1, actually. And we'll run that. So this particular program, and I'll kind of touch on this later on in the video here, but this program will print a globe. And I have the parameters pretty much memorized at this point. Oops. Okay, so this is drawing. This takes about 25 minutes, and you will see why shortly. And we're back to the PCUI blinking, receiving data from the Pocket computer. And it's going to do that for about 25 minutes or so. Don't worry, this video hopefully won't be that long, but in either case, I'll show the result toward the end. So let's see how we got here. How did I get that feature working, and what were some of the examples in the book? So what I did is I took the command set from the user guide for the FA-10, so it had all the commands that the plotter supported. I built support for those commands in the firmware in the PCUI. And then, really to test that, I had to run through the examples. Every command, every plotter command in the user guide had an example program that would go with it, a couple of lines of BASIC. And then I would enter that program, and of course I didn't do it, and I didn't type it in on the keyboard. I put this in removable drive mode, USB drive mode. I used Notepad and scanned the the pages of the manual in there, and I just copied and pasted. So OCR, dropped them on the SD card, and then just loaded them in ASCII mode here. So it's pretty quick with the PCUI. I avoided typing over here. So effectively, I got them onto the SD card in Windows, and then I would load them one at a time through the PCUI, through the tape interface there. So I ran each program. Each one would have a command that it would highlight, and then an example of how that looks. So the first one I did, it effectively just drew a triangle with another kind of square here, just showing the alignment and the point start and end, that kind of thing. So when I saw that the output was correct, I wrote that feature off as working, or working as intended, I should say. So there's an example of a simple plot. We have another one of concentric circles. So that was a demonstration of being able to draw a circle of various sizes and have the alignment be correct. This one is simple. It's just points. The plotter supports point styles, so you could have like a plus. This is very small to see, but star type points. There's just different point styles that it supports in the firmware. This was just a demo of, I think, start and end line points, that kind of thing, just to make sure that the points end to end line up. Another point demo. But what I was doing is just comparing the output to the user guide just to make sure that it printed correctly. Same as the circles, but we have squares because it supports the square command. And then this one was more of a, there's a homing command, or home command, I should say, for the pens in the plotter. So it draws two circles, rehome the pen and draw a circle below. That was actually tricky to get working. Text, the plotter does support text, so it has all the character map in memory, and it can draw that, every character with the X and Y axis moving, as we saw in the demo there. This is just showing all the various print sizes from point number 1 all the way up to the largest size that it prints. This one here was the rotated text. The plotter supports rotated text, so it can print in any pretty much 90-degree rotations there. This one was more of a axis support, so you can do plotting, function plotting on these. So that axis worked out okay. And then this one was more of, again, more alignment, making sure that the various shapes and circle, alignment and various, intersecting points there, making sure that it actually lined up, and that does, which is good. The plotter supports a grid feature where it can shade. So if you had a box, it could shade with horizontal or vertical lines, or both. So demonstrating that was interesting to see. The plotter also supports different line styles. So obviously, the plain line, which is a solid line, dotted line, and different combinations of lines, their line styles. And this seems very basic, right? This doesn't seem like it's very much of a challenge. But again, the plotter firmware did this, and now the PCUI has to emulate that, right? So that's what the feature is here. And these are just different. You can change the pointing, or I'd say the ratio of dot to line and the spacing and length of each, right? So these are the variations on the line style. This one was a challenge. This was printing a grid of sine, cosine, and tangent in degree mode, and then having it line up with cells, drawing the boxes and whatnot. So that getting the point size for the font to match up with the point sizing for the drawing was a challenge. And this is just a pie chart example. This is the only one I couldn't really figure out what was going on yet. The user guide shows us going all around the circles, and in mine here it kind of stops at this point here. So I'm not sure if the user guide has a bug in it or if my program does, but I'll look at that. To be determined, probably a bug in the PCUI. And then we have an interesting plot here. Again, a basic program that's maybe 5 to 10 lines of code, but the plotter can do this quite easily. and the PCUI is matching. We saw this one plot out a few minutes ago, just drawing a whole bunch of circles there. And then finally, one of the last examples in the user guide was this, kind of floor plan demo where it can draw a room layout or a floor plan with doors. These were like reusable. You could just, you put the coordinates in and it draws them wherever you specify, but the walls and whatnot. But again, this one worked okay. So the idea behind running each one of these samples and making sure the output worked was when you get up to, compatibility with existing programs, they should work fine, right? Because each of the commands work. So when you put them all together, it should work the way it was intended. And it was a lot of trial and error to get there. These are some of the failed, call these failed plots, right? So this is the text that didn't rotate. It took me a while to figure that one out. The point text and lines didn't really line up, so there's a lot of overlap there. That kind of was really exaggerated on this plot. The spacing there on the form feed was not quite right, so we were completely off in that alignment. Didn't have my third circle, so that one didn't work. And then I had issues with the centering of the canvas. So the plot worked, the printout of the canvas was off. This is probably the first one that I did. Not quite right. But again, this just shows, I wasted quite a bit of paper here. It's a good thing I don't have pens or paper to have to worry about with the PCUI, because again, these are very inexpensive. So with a lot of trial and error, I was able to get the full support working, which is great. And that led up to one of the demos that I often do with a lot of these pocket computers. I did this with the PB-100 and the FX-880. There was a publication in the early to mid 80s for the Sharp PC-1500 or Radio Shack PC2. And it was a demo program of plotting out a globe with all the continents that you can print in any angle, from any viewpoint around the globe. And that program is a relatively small program, and it was relatively simple when you look at how it's designed. And it just used a bunch of data points for the continent data or the landmass data. So that program was published in a magazine and has been used. There are several YouTube videos. I put out a few of them showing the plotters in action. And that plot takes about anywhere from 20 to 35 minutes, depending on the plotter. It takes a long time. And so, again, it just runs and plots. I have a full-page Casio plotter, and then I've done it on the PC2. I've done that on the FX-880p, for example, and now I'm doing it on this model. So I modified that globe program slightly just to work on this model. Maybe 2 or 3 lines of code needed to change, not that much. And that's what's running here. And so it's been running for probably about, I don't know, maybe 10, 15 minutes so far, roughly. And so, again, I ran into some issues with memory management, because storing 10 or 15, well, say 30 minutes of plotter commands, and in the creative way to do that with such little memory here in the Pico, I wasn't getting my plots. So the globe got a circle. That was about it. I tried, just debugging the program just to make sure that I didn't miss anything obvious. The first plot was just completely off. And then I found that, let's see, I think this is the next version. I was getting some of the meridian lines drawn, or longitude lines. And then I noticed there was a bunch of, looked like output at the top here with a bunch of overlapping pixels, and I figured, well, maybe I had everything shifted and it didn't really line up. And then I found out I was running out of memory. I was storing all those plotter commands in memory in the Pico, and then when the plot's done, it would then virtually follow those commands and emulate the plotter on its virtual canvas in memory. So I was running out of buffer memory. So I found the issue and then had the program stop after it did the grid, and I got it to work. I was like, wow, that is progress. So figuring out the memory issue and seeing the program get this far, I effectively then ran the whole program end to end And this is what the result was, which is success. So that globe program converted for the PB-700 using the PCUI and the plotter emulation. We're able to get a globe to print. And of course, the way this works, I mentioned, it just listens for all those plotter commands, and then it emulates on a virtual canvas inside memory in the PCUI. Now, when it goes to print, what I have it doing now is saving to PNG, a PNG file in the SD card, and then print that as an image in bitmap mode to the thermal printer here. It does the same exact thing, only in ProPrinter mode on an old dot matrix. So once we render the bitmap, it can be printed on anything. So this is an example of, technically it's a bitmap when it gets sent to the printer. And the PCUI is translating the plotter commands and creating a bitmap internally. And so this is saved as a PNG, so it could be reprinted or shared. You can copy the PNG file off of the SD card, etc. Whatever you want to do with that. And so, yeah, this is the result. So, you know, cumulative effort of trial and error, getting each of the plotter commands working one by one, and then when they're all put together or used in conjunction, if I got that right, then it should output the globe in the very same way that the original plotter did. So that was rather exciting to get working. Now, I mentioned this is the FA-10, FA-11 plotter, and the size of this printout is roughly the same size, maybe a little smaller than the original plotter that came with this model. And a couple of different points to note here, that the FP-100 is a full-page plotter. I have one of those, and that's the video I showed a brief sample from earlier. And that plotter, again, full-page plotter, the command set is nearly identical. I think there's only a few different commands for that plotter. So any program that's written for the FP-100 will work in this plotter mode as well, which is good. And the other thing is, I mentioned earlier that the Pocket computer is sending commands to switch, and it's commands by printing. It's sending a print command, right? It'll print 2 characters in a row. I can't remember off the top of my head what they are. Let's say it's A and B. So if the characters A and B are received by the plotter, it knows to switch into plot mode versus character mode, right? So in BASIC, you're just sending to the printer A and B. And then to shut off and go back to character mode, it might be B and A, right? Or some other combination. Now, any Pocket computer, this model only supported it only had a 4-color plotter. It did have a Centronics interface for it. Those are extremely rare. I've never personally seen one myself. So in theory, this could be connected to a standard parallel printer. You'd lose the plotting capability, though, by doing that. Other Pocket computers only came with a thermal printer, much like this one, just smaller. They never had a plotter. So for example, the Radio Shack, what is it, the Tandy PC-8, something like this, or the Sharp 1246. This is really a Sharp. One of the features the PCUI then can do for these other Pocket computers is not only emulate their printers that came with them, but in theory, you could write the same program on these and output the very same plotter commands. And so the PCUI effectively brings plotter support to print something like this or the globe or anything else to Pocket computers that never had that particular plotter, or any plotter for that matter. So that's another great feature of the PCUI. So that is the latest feature added to the PCUI, is the plotter emulation. So we can now continue to print, use any program that utilized a plotter with modern thermal printers or vintage dot matrix printers. So that is it for this update and that particular feature. Thank you for watching.